great factory, Akash, and great university, Sahil. Two remarkable entrepreneurs, two remarkable IITians.
It took 31 years for the mankind to industrialize the lithium-ion technology at scale.
How difficult it is to raise capital.
Raising capital is also very difficult. Without capital, you cannot build a team.
This is a big segment. Energy is a big segment, and there must be multiple problems to be solved. What are you trying to solve?
Electric has to be the only mode of transportation, so you have to solve the convenience piece.
Are there already vehicles on road that have your batteries?
1,000 vehicles in 37 cities are with clean electric battery pack.
If you were to design a new degree, is there a scope of, let's say, a BTech in energy? If yes, what would that kind of a degree look like?
Yes, we need PhDs and other research associates to solve for lithium sulfur or some fundamental innovation. That is also there.
So awesome day in India, rainy day in Pune, great factory, Akash, and great university, Sahil. Okay. Two remarkable entrepreneurs, two remarkable IITians, two also maverick in their own right. Akash, you're still very young, hardcore engineer, trying to solve an engineering problem to make India self-sufficient and the world in that essence, and solve the energy problem, which almost everyone is talking about. Few are solving it, and you want to solve it for now and future both, because the world is divided into two parts. Some people are trying to solve problem for now. Some people are trying to solve problem for future. Very few are trying to solve this thing for both future as well as for now. Remarkable persona. And Sahil, engineer by education, educationist, entrepreneur. When everybody was thinking of joining a large bank or financial services or opening their own company, Sahil decided to build a traditional university and bring change to the current education system, starting with Indian and with a global footprint, and make education future-proof, which is relevant to today's need and which is future-proof for the future which we are trying to create for this civilization per se. Thank you for both of you. Akash, introduce yourself in a much better way. Share your journey, in a sense, who you are, why you are who you are, and how do you see the future?
Thank you, Ravi. Awesome speaking with you today. And so I come from a humble family background. I was a traditional middle class family. My dad started also very early in State Bank of India from a very basic position, and now he's the chief manager at State Bank of India. So I have been to 10 schools during my 12 years of education because he keeps shifting every 1 or 2 years to different cities. So that was a very good experience personally, and makes you ready for tough condition. You have to find new friends every 1 or 2 years. So it was quite a good experience, and was always tinkering with a lot of things in my childhood days, whether it is washing machine, clocks, or whatever we all do in our childhood days. So there was an inclination for engineering, and somehow landed in IIT BHU in 2013. I met my co-founder Abhinav there, and during our BTech days in Varanasi, we built a lot of electric planes, electric cars in our college days, and represented India at global level in Singapore and Philippines. I still remember the day where we took our Indian flag on the stage when we came third internationally. So that was the feeling which cannot be explained in words, and that was the aha moment and the turning point. And after that, we thought we will not only build products for events which will be in labs in our IITs. We want to build something for our own country which can be used by general public. And then me and Abhinav incorporated clean electric during our final year of our BTech. And we thought of building and solving for electric vehicle ecosystem in India. Back then, we were trying to build a last mile delivery vehicle, but we realized that battery is one of the unsolved problem for today and tomorrow, which needs to be solved. We were able to source highly efficient motors from Bosch and other companies, but battery was something which was not there, and you cannot go and purchase a battery of your requirement from anyone at that point in time in 2020 when we started full time. Then we thought, let's solve this. If we solve this, this can be solved for car, this can be solved for trucks, two-wheeler, or any grid storage, any application. And when you look at the overall pollution globally and in India, you will see 25% is from automotive and then 25% is from power generation. So today there is a transformation happening in both the industries, and in automotive, electrification, autonomous and shared mobility is something which has changed the rule of the games. And if you talk about power industry, solar, wind and batteries are changing the rules of the game. And India, we are trying to be 50% renewable energy by 2030. That is what the Prime Minister vision is, to put 500 gigawatt hour of solar and wind by 2030. So in both these industries, which are half the overall CO2 emissions globally and in India, energy storage is the unsolved puzzle and needs to be solved differently for both automotive and for grid application. So what we have done in the last 4 years is, in case of an electric vehicle, it was not that practical back in when we started in 2020. So an electric car will take an hour or two to get charged, and there are still problems with respect to safety. We have seen a lot of battery fires, unfortunately, which is not good for the customer, for his or her confidence to buy an electric vehicle. And people always have a question about the longevity of the battery. So do I have to replace a 3 lakh rupee battery after 3 years or 4 years? So that is something, these were the three major pain points. And there was a lot happening in the energy storage industry at that point in time, whether you talk about solid state or graphene battery or diamond battery or nuclear battery. There is all sort of things happening globally. But what we thought, that Sony commercialized the lithium-ion technology in 1993, and we are in 2024. It took 31 years for the mankind to industrialize the lithium-ion technology at scale. Today, we have over 1,000 gigawatt hour of battery production happening globally, and all other technology, it is less than, it is not even in gigawatt hour as we speak today. So we thought, can we take a technology which is already proven, and as it is an electrochemical reaction which is happening inside a cell, can we play with it in terms of while creating a battery pack? Because in a battery pack, 33% innovations are there in a battery pack, 33% in the cell and 33% in the electronics. So rather than changing the cell itself, and people will take another 5-10 years to commercialize it and another few decades to scale it to where lithium ion is today, we thought, let's focus on the 66% of it. And we decided to focus on the electronics, which is the brain of the battery, which is called as battery management system. And how do we make new battery architecture so that we can solve that. So today, after 4 years, we have filed several patents in India and US. Today, as we speak, we have 4 of them granted in India and US. And we have an entirely different architecture. When you talk about the mechanical, it is a direct contact liquid cooling technology, which is different from how Tesla and Rivian has solved for their application in the West. And we have chosen a different way to solve it for India and other emerging economies. And on the software side, we have our own proprietary algorithm, which manages the battery in a way so that you can charge those batteries in just 15 minutes and still have 3000 cycle life or a 1,000,000 kilometer battery life, so that you don't have to replace a battery in the entire lifetime of an automobile. And we have made it idiot-proof safe. So there is 5 layers of safety built into the battery. And even if your electronics malfunction, there is a direct contact liquid cooling jacket, which is a non-flammable liquid, which is there in the battery, and your battery has very less and very little chance of them getting into fire because of 5 layers of safety which we have put on this technology. So that is how we have gone about solving it for the automotive. And similarly, we are now scaling that similar technology into megawatt hour scale battery storage, which is a must if you want to increase the wind and solar penetration in the base load, which is like today we are 250 gigawatt hour of base load, which is there. And we change between 200 to 300 gigawatt hour if you look at the instantaneous demand. So if you need to get 50% renewable, wind and solar are intermittent. It is not like you push in coal and you start generating electricity. They are available at day, they are not available in night, and wind is also non-predictable. So storage is very critical if you want firm dispatchable energy. A green energy is a different thing, but if you want to solve for green dispatchable energy, then storage becomes a very critical part of it. And we are very excited. We have already deployed first pilot with certain customers in India for grid battery, and we look forward to scaling the same into megawatt hour scale to support this transition to renewable energy.
So Akash, these are times for Olympics. Okay, you have represented India before when you were a student and post your education. Do you think India has a stand, a medal stand in the Olympics of energy? And the rationale behind it is that every country in the world have their own definition of energy as a crisis and energy as a solution. Everyone has their own context in terms of climate and their own view of future-proofing this particular climate for the good of our planet, right? You look at European countries, Germany to Spain, similar kind of setup. You look at Russia, very, very different kind of setup. You look at US, very, very different kind of setup. You look at France per se in that European Union, very, very different kind of. Japan has a very, very different kind of setup. China has a very, very different kind of setup. Our neighbors, Bangladesh, Pakistan, Sri Lanka, they have a very, very different kind of setup. Vietnam, South Asian countries, Singapore, Vietnam, stretch apart. Malaysia, somewhere similar to India, but a different point of view. In this context, and I'm not talking about Africa, okay, which is altogether a different ball game in terms of how do they define the need for energy per unit versus how do they want to future-proof their own continent and different countries within Africa to do that. In this context, you are in India. Your problem set is India-based. India itself has its own unique view, which is both global as well as domestic view in terms of solving energy problem. Where do you see yourself? What is your view about the current opportunity which exists in India, and how future-proof you can build something in clean electric and in which sectors?
So to simply answer your question, in sports, when we will become top 3 is a question mark, to be realistic. But if you're specifically talking about energy, I think it is round the corner. It is not that far. And I firmly believe that India will redefine and will gain its leadership in energy sector in the top 3 places, definitely globally. Why I am saying so? Because if you look at India, we have 7,500 kilometers of coastline. We have ample of wind energy, coastal wind energy available. If you talk about India, we are at the equator. We have sun 12 months a year, which is not very common. Every country has its own thing, but we have sun 12 months a year. That's put us in a very unique position to harness solar. Talking about wind also, Gujarat and a lot of other states, Tamil Nadu and all have very good potential of wind as well. So as a country, like you mentioned, every country is a unique. European countries are more dependent on wind, not that much dependent on solar. But India, we are focusing on wind, solar and everything. Even to that matter, we have pump storage, we have huge hydropower plants in the north of our country. So we are very conveniently situated from a latitude and longitude perspective. And I see a clear path for India to lead and show the world what is the right way to go about renewable or sustainable energy. And the price to build a thermal power plant is 6 to 8 crores per megawatt. Wind is less than 6 crore. Solar is around 4 crore rupees a megawatt. So from that perspective, it is cheaper to set up wind or solar plants. And the kind of leadership we have at the central government, especially talking about Solar Energy Corporation of India, SECI. Now India don't have the vanilla solar and wind tenders coming out. Now India is coming up with a hybrid tender approach where they are asking for dispatchable energy. Because solar is 2.5 to 3 rupees a unit. Same goes with wind. But what we are seeing now, we are seeing dispatchable energy reaching a price of 5 to 6 rupees a kilowatt hour, which is unheard globally. The kind of storage tender which has been gone in India, where we have allotted 2.5 gigawatt hour of battery storage for supporting the grid requirement, we are at a record low level. If you compare us with US, I think it is half or even better the prices per kilowatt hour Indian developers are giving. So in a nutshell, we have enough resources from a solar and wind perspective. India is charting out its way. The kind of tenders which are coming up with firm dispatchable renewable energy, FDRE, which has come up recently, round the clock, where government is asking for 400 megawatt of round the clock power. So I think India can replace its base load with renewable in the in the coming future. And we will lead that example that how to marry coastal wind potential, hinterland wind potential and solar with energy storage in a big way. And the kind of prices which we are looking at energy storage, the lithium ion to what it is today, it is very logical for any kind of load to go green. And India will have its own innovation to have decentralized energy infrastructure. Pan-India, Pradhan Mantri Solar Yojana is there, where they are giving subsidies to set up 2 kilowatt in different sizes of solar. So India will set up its own way of how we solve for our country. Yes, distribution is a bottleneck, which is the last mile distribution in India, which is the discoms in cities and the rural or the urban cities. There we have bottleneck. We have a very thick pipe when we have to do interstate transmission of electricity. But when we talk about the 11 kV and the 33 kV and the 400 volt city distribution, there we have some bottleneck. But with energy storage, we can solve that without putting up a dedicated transmission line, because we need the power only in peak hours, evening peak hours or morning peak hours. So we have to go a long way to do that. And more in terms of modernizing our grid. We are quite behind where US and Europe and their energy markets are today. They have a proper stock exchange for all the energy trading. But in India, it is not that evolved. So there is a lot of modernization which we have to bring into the grid to automate the grid and all that, so that it will solve for two things. It will solve for EV penetration as well as renewable energy penetration, because you need to match the load and the demand. So that is something which we have to work and solve towards. But once we solve that last mile, which is the city distribution network, we are good to go. And it is also not that challenging. It is putting digitization of grid and all that, we'll be able to solve a lot of things. So to answer your question, yes, definitely we will be the leader in energy globally, maybe in 10 to 15 years.
So this brings to the, you used hybrid, and I agree with that. Also, I think the economics and the rainbow of problems which India has, I think if we solve that particular, all these problems, I think we'll solve the global problem. So I agree on that. Now, I'll not get into the geopolitics of periodic table, okay, because you're an engineer and I have written much about it, and probably I know more about the subject of periodic table and the politics of geopolitics of periodic. So if we keep that aside, there are two major discussions which are happening in India. One is pure play electric, one is hydrogen. One, the science and the chemistry part of electric, and in a very, very similar way, the physics and the chemistry of hydrogen. Okay, right? And then there is a commonality, which is a applied engineering game, which is playing. There, I would like to pick your brain that what do you see? Are they going to compete? Are these going to compete? Or as you say, they are going to be a hybrid, both from the practicality of a large country like India and its real problems in terms of distribution, and also different sectors, right from two-wheelers to an aircraft, right from a small home in village to a huge condo in Mumbai, etc., etc. But also a little bit of a brief on what is the playground for science over here.
True. So you're specifically asking about the hydrogen and the electric revolution which is taking place. Electric has already come to a certain level, and government is spending so much time and effort in see how hydrogen can play a role. Since I have seen India's largest steel plants and cement plants, so to simply either
to say that policy-wise, electric is way ahead because government of India has created policies, but political will and the backing is more towards hydrogen in a sense. The posturing is happening that okay, we'll continue to do electric. EV is one of the biggest use case for that. But there is thought process and a huge lobby which is actually pushing for hydrogen.
Correct. So at the end of the day, government push is critical to drive industry. We have seen how China has outperformed every country in the world. So that's a great example. But there is something you can push, and then at the end of the day, to truly scale something, from my personal point of view, I think there has to be a pull, and market has to decide what is right and what is wrong. And you can be very factual and logical about these things. So I think in electric vehicles, in a lot of things, electric will become a primary mode of transport. And in limited applications, like if you have to do a Mumbai-Pune truck, a 48-tonner truck, there hydrogen could be a better use case because you can refuel in minutes, in less than 5 minutes, and you can keep the up. So there will be applications to solve. And what I see, we only talk about energy, or we only talk about transportation, but steel has 10% of the global emission, steel production. So cement will have a similar, I don't know the numbers, but significantly when you are talking India and global. So in these sectors, they are already using hydrogen, which is a grey hydrogen, which they are making from a fossil fuel. But a green hydrogen has a role to play here. So these sectors, whether it is steel, there are different processes of steel making. One is blast furnace, one is DRI. So in case of DRI and the other processes, which is electrical arc furnace and all, their hydrogen will play an important role. And you will see companies like JSW Steel adopting that ethos in their future roadmap and the focus towards the ESG and building steel responsibly. And there could be a premium for a green steel, who knows? So automotive wants a green steel, and they can say that our scope 2 and scope 3 emissions are so and so. So we never know how the market will develop. So their hydrogen is the important thing. And renewable electricity is also critical to run electric arc furnaces which run on electricity. So I see it is complementary. And yes, there might be lobby for certain things, but that will push something to a certain extent. But at the end of the day, it is pure logics which drives things. Whether it was with respect to DC transmission line or AC transmission line, the war between Edison and Tesla. So whatever is logical wins at the end of the day from a different perspective, not only efficiency, practicality, safety and all other things comes into picture. That is why AC transmission wins, because of the safety thing. So same thing will happen here. just to give a quick math, if you are producing 100 kilowatt hour of renewable energy, if you are putting that into an electric car, maybe 85 to 90 kilowatt hour has been converted into useful work. But if you do the same math with hydrogen, because it is very easy to transport electrons in a transmission or in any network which India already had. But if you have to do it with hydrogen, then it is a CNG problem. And CNG took decades to set up a CNG station, and it is in tier 1 cities, to be frank. CNG is in tier 1 cities and now getting into tier 2 cities and all. And it has been 2-3 decades of work to solve that. Same is the case with hydrogen. So, and again, hydrogen, you have a lot of problems. First, today you have renewable electricity, then you can make green hydrogen, but the efficiency is 50% of a fuel cell or something like that. And then you have to compress it to a refrigerating point so that you can compact it. And then again, you put it into a car, again, you will have a fuel cell. So 30 to 40, if you started with 100 kilowatt hour of renewable, you will get 30 to 50 kilowatt hour of useful work done by an automotive application. So, which is not that logical. So, if you can get 2x of that, why to take this route? So, infra is difficult and all those things are difficult. So, there will be certain application where it will require like heavy haul trucks. It will find a use case there. I think Reliance and other companies at Toyota is trying to solve for that, how they can use hydrogen and rather than using in a fuel cell, use it in the combustion chamber. So with today's technology, it looks difficult, but let's suppose tomorrow we have different kind of electrolyzer or whatnot. Things, our perspective may evolve, but that is the case. So my take will be automotive, primarily it will be driven by electric. Maybe in aircraft, it will have a say because battery is very less energy dense if you compare with gasoline or hydrogen. So electric aircraft, there might be a way ki they uses a mix of hydrogen and electric propulsion. But in automotive road transportation, I see more of a electric. But in hard to abate sectors like steel production or cement production, cement you have to heat a lot of things. So hydrogen can be used. Steel again, you have to heat a lot of things. So hydrogen can be used. It has very high specific energy and so it can be used there. So hard to abate sector will use hydrogen and that will be the primary consumer of hydrogen I see. And transportation, road transportation will be more geared towards electrons because they are easy to transport and no infra is needed to do that. So that is how it should evolve from my perspective.
That brings me to the last one and then Sahil will carry on from here. So you solve a problem, you create a product which is a solution. You figure out how to scale it, but you need people to consistently build a business and scale it faster than your competitors, both existing large players and the incumbents can do that. Now, while yours has been a very, very remarkable journey, what has been your take in terms of pure play skills which are available for the industry which you're talking about, which can do the job or which can help you to scale the factories and the supporting organizations functions which are there in clean electric?
Yeah, so team building I think is the most important part of building any product or any company, I will say. So whether someone has built Lockheed Martin and other aerospace companies globally, so I think team is the only thing which defines how good or how bad a company can be. And talking about the case of clean electric, we are in the energy sector and we have to solve a multidisciplinary engineering problem. So we have to solve the chemical equations, we have to solve the electronics, we have to solve the software, we have to solve the mechanical architecture, the cooling architecture. So we have a very multidisciplinary team. And me, Abhinav, Ankit are the part of the founding team, but we cannot do anything. We just have some ideas and some thought process how we have to solve it, but we need a large team to do that. And our collaboration started way back in 2022 where you spoke to me and Abhinav and you thought we are doing something interesting. So I will say our true journey started with that. And we were able to attract capital, which helps us in building a team. Without capital, you cannot build a team. Today, we have people who are from different IITs. They have their own aspiration, their own lifestyle. They were working in an industry. So we are very lucky to have a very good team, R&D team of 40 individuals from different IITs and different good institute. We have team members who are not from IITs, but they are doing remarkable innovation because they have a love and passion for engineering. So the lot of the talent we have to develop in-house, because when we started in 2020, there were no company in India building battery packs or solving energy problems. So what we have seen when it comes to core innovation, what we have done, we have gotten people on board and we have seen do we have similar synergies or similar vision or not. If that is there, we have worked on it. But there are some cases where we didn't find the synergy or we didn't find the engineering love. And if that is not there, we cannot work together. So, but luckily we have gotten a lot of people, and earlier our thought process was get an experienced person and do it. Get the things done. He will run his department and all that. But it has evolved over times. Today, like 5 students from IIT Delhi and IIT BHU and other colleges has come for internship, and 10 I think, and we have given replacement offer to 5 of them. So we think that is the better way to build a team, because if you want to solve for innovation and the areas are very emerging, you don't have that much talent in India. So we have to work together, we have to build understanding, and we have to develop the innovation team in that way. But when it comes to scaling up things and when it comes to industrialization and all that, because we want to build scale, we are here to innovate, but scale also gave us some joy, and we also want to build a large business out of it. And we think there are a lot of innovation in manufacturing and there are new ways to build something. That is the reason we are innovating there as well. There we have found a good talent, whether it is project management or it is manufacturing or whether it is growth, having industry connects and all that. So there we are getting a lot of good people from the industry, from IIMs or from consulting, McKinsey and other companies. So they can help us build a very high performance culture and execution culture. And that is also equally important, because innovators want their own place, own comfort. You cannot poke them too much. You cannot have a project management team when you are innovating something. And innovators work at their own freedom. But when it is about execution and scaling thing, you need discipline there. So that is how we have gone about building team. We have got experienced person who have scaled businesses, whether it is startups or whether it is tier 1 automotive component industries and all. So there we have found some like-minded peoples, and we have built those teams from industry. So that is how
you brought the word capital I didn't. Okay. Yeah. How difficult is entrepreneurship, Akash? How difficult it is to raise our capital? How difficult it is to attract talent which you want? How difficult it is to scout for that particular talent and somehow get them be a part of your vision?
It has evolved, and raising capital is also very difficult, especially in India and especially deep tech or hardware, or it is not like 3-4 people sit together, code something with laptops and all. We have to build things fail, things don't work in the first time. We have to keep investing for years. There are some projects which we call the Great Experiment, which was the foundation for our software algorithms, which are enabling 15-minute charge for general purpose affordable technologies, which nobody in the world has done. So we have spent 2-3 years. First 2 years we failed, and the third and fourth year we found some success. So when we are building a product, hardware and software, capital is a must. You cannot. For the first 2 years we were bootstrapped, and there was limited progress which we have made. Past 18 months we have been funded by institutional investors, we have grown a lot. Whether it is in terms of team and setting up infra, because you need all that if you really want to innovate on the hardware and the product side. So we'll come to that. It's a difficult thing and all. We'll come to that. But talking about the team is very critical. And earlier we thought good engineer will speak to us. They will see our passion and energy and they will join. That will work if you are lucky, but then you have to create a brand for yourself. And then that is where we started focusing on the marketing bit of it also, so that people know what clean electric truly stands for. So we have to spend some time over there to build a brand and to truly communicate with everyone that what clean electric is all about. So that becomes critical, and we continue to spend on that side because people are proud working with Tata Motors because everyone knows Tata Motors. One of my team member asked this, sir, when I talk to my relatives, they don't know what clean electric is. So that is where it pinched me a lot that I am okay if nobody knows what I am doing, but people want, and when they talk to their relative, they want, their relatives want to know that their known person is working in some good company. So that is where we started focusing on that very few months back, and we will continue to build there, and that is a way you can attract and retain talent. And you have to be a good human being if you want to retain good people, because they don't like that bossy culture or that whatever director has said that needs to be executed. So there is a different kind of culture building which Abhinav, me and the leadership team has been trying to build, a relatively open culture without any hierarchy and all that. So that is how we are going about it. And we have also not cracked it. There are a lot of people who don't join, which we thought they should join. So we are also learning that piece. But we will eventually get there, and we'll set a culture where people are not scolded for some failure. So when you are innovating, you have to fail 5-7 times. Then only there will be a substantial innovation which can impact humankind. So that is the culture which you have to embrace. And we are also trying to learn how we can do that in the long run and be disciplined also along the way. Coming about raising capital, it has been difficult in the early days since we are fresh people, and Initially, we said we will build an electric truck. Nobody trusted us. So we limited our scope and we say, okay, now we will solve an energy problem. So startups cannot take large problems, especially first-time entrepreneurs. There is a difficult in building that trust and all. But once you have done something, not in terms of raising capital, but building businesses, building long-term sustainable businesses, profitable businesses. Anyone can build a business by burning money. But if you can build something like that, then I think in second time when you are very audacious or in your thinking that you want to solve something really big, people will trust you. And it is not always a very enjoying journey, I will say. Yes, from an outside, it looks like that this person has raised X $1 million and tens of $1 million, but the process could be improved. But I think it is what it is, and it is capitalism, and everyone wants to make want a pie or something successful. So, whether for an innovator, I will not recommend ki, build something. Whether it's a very a lot of times there are so low points that we really think, why are we doing this? What is that driving you? If that drive is not stronger, you will eventually give up. So there has to be something, and it cannot be money, it cannot be fame, it has to be something different, I think, if you want to build something big, because in product or hardware, you will need a lot of capital. Without that, you cannot build a business unless you come from a very rich family.
So, Sahil, this is a good point where you need to pitch in, because you are trying to solve this this question. Why should I get into this? You have also created Rishihood University to build a character, to build leadership. to create entrepreneurs. And your thinking is beyond engineering per se. You want to create. Also, very, very similar disruption is happening in education. So-called online model, which was supposed to be the model, is now challenged, very politely.
Yeah.
And whether universities from outside will come to India, or it is India's time to build university for domestic as well as for global consumption, is a question which everyone has. So, and here is an entrepreneur. Both of you are from same alumni. IIT, it's a known brand. So, over to you now. What do you think about this question which Akash has raised, and the business, if I can call that business, or should I say karma of building future, great character, great integrity, great leadership?
So Akash, it has been a fascinating journey. And जितना भी मैंने आपके बारे में सुना है, पढ़ा है, this is a big segment. Energy is a big segment, and there must be multiple problems to be solved. उसमें से what is exactly that is clean electric's mandate? What are you trying to solve?
First of all, we have not achieved something that big. We are in the very initial phase of the company building and organization building. And I will say less than 5% of what we should be doing in the decades to come. So we are in a very early stage of our part of the journey. And talking about what we have solved and what we aspire to solve. So like we initially discussed, so we think that if you truly want to have an 80% kind of EV penetration, today it is less than 5% and 1 or 2% in different segments. But if you truly want to transform this and the new vehicle sales, and we want 80% of whether it is car, bus, truck, anything to be electric, we need a different kind of approach to do that. So what you said, future-proof, the word which you used. So first of all, there are two things which is important for any new technology. One is cost and one is convenience. So what we are seeing yesterday, Curve EV was launched. It was launched at a similar price point, that of Creta EV. So now we have come to a place where the technology is mature enough that we are trying to get to cost parity. If not cost parity, I will say 20-25% here and there compared to combustion engine vehicle upfront. But if you talk about total cost of ownership, EVs could be as 20 to 30% less expensive if you look at fuel cost and TCO basis, total cost of ownership basis, for any segments if you have a decent kilometer driving daily.
This will be true for two-wheelers, three-wheelers, four-wheelers.
Correct. In two-wheeler, we have already reached price parity. Ola is selling products at 80,000 rupees, Activa is 110,000 rupees. So, and the cost of operating an EV, like 1 unit of electricity, you can run 25 kilometer. 10 rupee of electricity, 25 kilometer, 25 paisa. And Activa will consume 1 liter for 30-40 kilometer. So it is 10 times more if you talk TCO basis. And same goes with car and other segments. So that is very clear now. So what is unclear, that EVs are not as convenient as combustion engine vehicle. You drive to a fuel pump, you refuel your car or truck, car in 3-4 minutes. I have clocked the time. In intercity bus, when I travel 800 kilometer in a Volvo or something, it will take 15 minutes, 10 to 15 minutes or maybe 20 minutes, because it is also a P brake or some other things are also mixed together with that. So if we solve convenience, I think EVs are a no-brainer from that perspective. And with convenience, we need to give customer the peace of mind, whether it is with respect to battery safety or whether it is respect to that they don't have to change their battery in the overall lifetime, like they don't have to change their engine in the 10 or 15 years of owning a car or a two-wheeler. And they don't need to waste time standing at a fuel station or on a long trip. Otherwise, it will be always a secondary mode of transportation. People will have a combustion engine car, and for grocery shopping and all, they will have a EV. But we are not here for that. So we are here that electric has to be the only mode of transportation. So you have to solve the convenience piece. They should be able to refuel in minutes rather than hours. So that is where a 10 to 20 minute charging time becomes very critical if you want to have an 80 to 100% EV penetration now. And if we are selling 30 million automotive every year in India combined all, we have 300 million vehicle park, because a vehicle life is 10 years. Whatever we are selling in a year, 10x of that amount will be the total vehicle which is on road creating pollution. So right now I am only telling the new vehicles sold should be electric, but that has to happen for 2-3 decades to remove all the combustion engine which is causing pollution. And it is very scary once you look at the smaller things which is happening in India. So Delhi is 55 degree this year. It was not the case 1 year, 2 year, 5 year, 10 year back. You cannot go outside in summer days in Delhi. That was a very different thing. Kerala is into floods. People die because of lung diseases because of air pollution in the city. So it's a very deadly problem which needs to be addressed, and the good engineers should work on solving this. And how Clean Electric has done it? We have built a energy technology, the battery technology, which charges in 10 to 20 minutes depending on different application. They don't need a proprietary charging infrastructure. It can be charged in 10 to 20 minutes on a universal charging network. Your C-type mobile charges your iPhone and your headphones, your laptops, everything. We just want that same experience with electric vehicle. There has to be interoperability. There has to be standardization to be able to truly scale electric vehicle in the nooks and corners of our countries, villages, tier 2 cities, everywhere. So that is how we have been trying to solve it. As we speak, we have a two-wheeler standing downstairs which gets charged in 12 minutes using a public charger. Now we are working with three-wheeler OEMs, electric car OEMs, commercial vehicle OEMs to scale this technology into three-wheelers, car, buses, trucks, and other form factor of electric vehicle. And since it is one side of the story, we are solving for tailpipe emissions with electric vehicle. Cities will not have cities will not get polluted because of the cars which are giving you smoke, or buses. In Mumbai, there will be a red bus which will put tens of kilos of black smoke in your lungs if you are traveling in an auto. We want to change that. But in order to solve for well-to-wheel efficiency and well-to-wheel emissions, we need to solve the later part, which is the energy generation. Energy is generating via coal plants. 70% of our grid is coal or different fossil fuels. That also needs to be changed. So now we have started working grid storage batteries, and today we have deployed 60 kilowatt hour battery. Now we want to deploy megawatt hour scales and eventually gigawatt hour scale battery packs which can stabilize the grid. So these are the areas where Clean Electric is innovating at this point in time.
Are there already vehicles on road that have your batteries?
1,000 vehicles in 37 cities are with Clean Electric battery pack as we speak. And in next 1 year, it will be 10,000 vehicles, new vehicles, which will be with Clean Electric batteries in the next 12 months.
Amazing. One question I have is that since so much input is going into this ecosystem, what are the dependencies that we have as a country on raw material, particularly on rare earth material? Because I'm assuming that is one of the critical components of enabling this.
A very correct question, and we were discussing before this discussion that how our dependency on lithium-ion cell on different countries and semiconductors, even if we are doing all the rest of the innovation in India, I think that is what 30-40% of the value addition. But still 60 to 70% of the components we have to buy because we have zero semiconductor, zero fabrications happening of the chips in India. With PLI for lithium-ion cell, India will have a 40-50 gigawatt hour of capacity in the coming years. But today it is non-existent. And initially, we will have dependency for cathode active material from other countries. In a cell, there is cathode, anode, and anode we can produce it in India because it needs carbon graphite that we can do it in India locally. We are self-sufficient in that. We are self-sufficient in copper, aluminium. which goes into the battery and which goes into the other parts of motor and other things as well. And when we talk about lithium, we have got some reserves, but it will take many years to be mined and then to be refined. So the refining of the cathode and the anode is something which will be critical. Anode is something little simpler as compared to cathode. So in cathode, you will have nickel, cobalt, manganese, and all these things. We need to set up refineries to make the production of the cathode active material which goes in the battery. So those are some of the things which we might have to be dependent on other countries for some critical raw materials. But if sodium matures in future, so we can also think of how we can make it more self-sufficient. So that should also be a thought process. But I will say we have most of the critical minerals, and government is already making some new joint ventures, and they are partnering with Australia and Kul and different countries which are having lithium-rich mines and all that. So there is already some Khanij, which is a joint venture of 3-4 PSUs, and they are working towards securing raw material for self-sufficiency of India. But any day it is better than importing hundreds of billions of dollars of crude oil, because you have all the renewable which you can produce in India. So that dependency will surely reduce. And we also need to have a clear focus roadmap. So in a central government also, we need to be having a clear strategy and long-term strategy when we are working in this direction. We cannot be confused all the time that we will do ethanol, methanol, electric, hydrogen, hybrids, powerful hybrid and all that. So market forces will also decide, but as a nation, we should also bring more clarity, doing more deep dive with what is the actual greenhouse gas emission of ethanol versus electricity. When you compare those things, you will see electricity is a obvious choice. So we need to, as a policies framework also, we need to don't always trust all the consultants. We should also do our own study and really see that growing a crop, harvesting it and processing it and making ethanol versus generating energy from wind or solar. On an overall GHG emission, what is better? That also can make better uses of our land resources and all those. So that clarity and long-term thought process, if there is in government, and it has to be logical. I'm not saying it has to be electric. Do your own research. If you find that, yes, this is a better way, then focus more energy in one direction. Because there are multiple ways to go zero emission. So we should have some inertia going in one direction. That becomes critical.
I think along with the dependence on material and technology, it is coupled with the dependence on talent, in the energy segment. Because I come from education, I'll always get intrigued on how will future students be relevant for this, broad energy segment. And the way I understand from what you're saying, it's a mix of some bit of mechanical engineering. So I'm a mechanical engineer. I'm understanding some part of what you're saying. Probably some of chemical, probably some of computer science or electronics. But if we look at those degrees fully, probably a lot of that is not relevant either to energy or to anything else. If you were to design a new degree, is there a scope of, let's say, a MTech in energy? If yes, what would that kind of a degree look like?
So today, I have a different view there. So today, if you look at educational institutes, we are creating more data scientists, we are creating more software engineers than engineers in the core engineering field. Like I am talking about my college in IIT BHU, I would say CS is into software. Electronics, I will say 70 to 80% will have gone into software, and 5 to 20% might be doing electronics. If we talk about chemical, I will say less than 10% or less than 5% will be doing chemical engineering, and the remaining 90% will be doing data science and product management and other.
From my batch, out of, I think, around 100 of us, 2 people ended up actually doing something on mechanical.
So that is the story. So more importantly, creating a new engineering field, I think it's a multidisciplinary approach, and it is an engineering problem to solve. And yes, we need PhDs and other research associates to solve for lithium sulfur or some fundamental innovation. That is also there. But if we can bring that focus from software industry to core engineering thing, and we have very limited opportunities. A good chemical engineer will earn how much? 5 lakh, 10 lakh, 15 lakh. A software engineer will earn 25 lakh, 30 lakh. Okay, but are their skill set completely different, that this person should deserve a 30 lakh and this person should deserve a 10 lakh? So these are some of the kind of most difficult problem to solve. Are we valuing the core engineers who are investing time in electronics, electrical, chemical that much? Because everyone is smart and everyone wants a good lifestyle and everything. So a smart engineer will go and do data science or software, whatever he has to do to earn 30 lakh, 40 lakh or whatever lakh. So there is some shift which is needed to attract people towards core engineering field, and the time has come. India needs its own semiconductors. We need to build our own chips. We need to build our own technology for electrification, whether it is solar, wind or energy. So we need engineers of all interdisciplinary engineering to come back and do the real engineering. If the IIT is having such numbers and such threshold of 5%, 10% or 20%, then what we can expect from other engineering colleges? So more importantly, rather than creating a new branch, I will say what we can do to bring talent back to solving core engineering problems. And I have a personal suggestion that I have faced a lot of hardship, me, Abhinav and Ankit or whosoever are doing some hardware products, or I will speak for all other hardware engineers who are trying to build some product in India. We don't have a process where a student team can get some resources, money from an institute to build some product. We don't have that processes. We had find our own ways, but if there are 100 engineers, 10 engineers want to do something, only one engineer can get the resources to build something. That should not be the case. At least 10 engineers should be able to build whatever they want. So if we can solve that in some way with whatever committee, taking alumni also into that committee, not limiting it to professors, and so I think we can solve something. So
I think particularly looking at your own journey, as a student, where some of the funds that you got that time enabled you to create, I think we need to institutionalize this. That's also what we are trying to do at Rishihood, because we provide a startup funding to all the students, so that when in their college life itself, they can experiment and fail. And Ravinder ji is helping us build that kind of an ecosystem where no student should exit the university without taking a risk. And when that happens, their mindset is already ready to get into the world of entrepreneurship.
And I think it was not a choice. I or Abhinav or any good engineer, but I will speak for me, Abhinav, Ankit. We were not trying to build a company. I think because all three of us has built electric cars, electric planes, go-kart, FSI and formula cars and everything, it's internal. It is automatic that we wanted to build a good product for our country, because as a responsible engineer, if we are not doing that, who do we expect to build products for our country? We don't want only Teslas of the world or the Apple or the Nvidias of the world to do innovation. We want better engineering companies challenging the status quo. So I think if an engineering student is building some product in his college days, I think entrepreneurship is solved.
And to your question on learning, I think this is learning in action. The way I see startups of today, they are like micro universities. Real learning is happening in that kind of an atmosphere where there are pressures, there is a objective, different young people are coming together trying to solve something. And in that process, a lot of learning is happening. I think that's how future education will look like, where we are not teaching institutions, we are learning institutions. And we have to build that enabling environment in our campuses so that learning happens, tinkering happens, innovation happens, risk-taking happens. And from that, what will emerge is that mind where Someone will be interested in developing a new product, finding a solution to an existing problem, rather than just thinking what my peers are doing and going with the flow.
Correct. Today also we are using the same books to solve the problem of energy. We are literally using our mechanical engineering books and courses to solve whatever is there. Even you have to go to your school books to solve for what any complex problem. The solution is very simple, and it is the same formulas which are driving, whether it is aviation or energy or any topic for that matter. So a drag is as simple as half mv square into coefficient of drag. And how do you make a electric plane or anything for that matter? You have to bring down the coefficient of drag. In case of vehicle, you have to bring down the mass. You have to. So these are all basic things, and starts basics. We have the basics, but if we add a practicality and people tinkering to build something using that knowledge, I think that will truly differentiate. And what we don't have, if students and engineers have that in future, I think India will do superb, and we also will have a similar progress to that of MITs or the tier 1 institutes globally. I think our people are running the big company and are working in Tesla or Nvidia anywhere. So if we can institutionalize that, I think now we have all the capital. People are looking at India to invest.
The opportunity is extremely exciting. I think just like Akash is saying, we'll definitely get the medal in the Olympics of energy. I think that's also going to happen in the Olympics of education or Olympics of learning, because if we can teach a student to solve for a scale that India has, with the kind of limited resources that India has, and that student can excel in any kind of environment.
You have touched the right topic. If we solve for India, like Ravi mentioned, we solve for the world. Why do we do that? Because in India, everyone wants free. If we can solve a problem at the expectation of an Indian consumer, in a US and Europe, people are ready to pay 4x, 5x, 10x price for the same thing. So if you are solving for India, if we are producing 3 rupees a kilowatt hour electricity, everyone in the world needs affordable electricity prices. Look at the prices of electricity in US and Europe. I think they are 15 cents or 20 cents. So 16 rupees. So that is what, if you solve for India at the expectation of Indian customer at a cost point, you solve for everything. And that is not a good thing also. There are a lot of innovation which are not happening in India. Why there is no aircraft company in India? Why we don't have Boeing and Airbus in India? Because when we do our maths, we think यार customer तो pay नहीं कर पाएगा ये price. इसीलिए Western countries जो critical areas वहाँ innovate कर पा रही है, क्योंकि वहाँ पे वो risk capital है, वो इंडिया में वो risk capital नहीं है. And that is the reason we don't have Nvidia of India, or we don't have supercomputer chips somebody building in India. Because when you have to solve that kind of problem, investors will ask what is the market, what is the unit economics and all, but our Indian customer can pay that price. That is why we have limited global products. So someone needs to solve that.
That's not a matter of if, it's a matter of when. It is going to happen. If we keep compounding at 8% for 10 years, we will have that risk capital. But when we have that risk capital, will we have that talent to make use of that risk capital? I think that will be an important question to answer.
Correct.
So I'm convinced that India's solutions will be global markets. There's no doubt about it. Because whatever, first of all, we are so rich in problems, and there's so many problems that if we solve it, that has to be solved at the delivery point. So it's acceptable in this particular country. Okay, so even if somebody else has solved it, the real economics will be another thing if he solved the same problem. I think the question which Akash reads as in meaning, because I tried my senses of that, is a troublesome one. Here, I think universities, I'm not going to blame anyone, colleges, university, that carefully think about it. If during the incubation and adoption of knowledge, professors are giving knowledge and students are absorbing it, the mindset gets so tuned that look, at the very, very early semester itself, I am going to systematically tune my future towards a particular check science. Then we were not in the because look, engineers apply science. We are not the creators of science. We should never even claim that particular that, but it still is for a physicist or a person who is discovering or a particular element either on a periodic table or conversion or multiples of that to the realms of physics. We as engineers, we have one attribute which we drive on, which is curiosity. And you cannot just enclose or constrain this curiosity as by the way, it's a data science, or by the way, it's computer science, or by the way, it's machine learning, or by the way, it's deep, or by the way, it is capacity rates. By the way, I became engineer because I wanted to build things. Okay. And I never thought when I was reading a boutique arm that, by the way, my major is in computer science. And frankly, most of the work which happened in the minor thing, which was aerospace, in terms of machines which are built. And of course, the computer science team very happy a sense because it was a wrapper to those curriculum machines. So it's not about chemical engineering or it's not about computer science. But culture, which somehow happens in the early semesters that you at Akash, so you will do and so that means that you write code. And frankly, not that quality as code. You write a quality level, which by the way, you don't have to be an engineer to write that quality as code, right? And it can be anyone. Like you don't even have to be a graduate to write that code, right? Quality of code. It is just that, look, they're just so tethered in that 40-50 lakh rupees that you forget that is, the whole ecosystem, the whole infrastructure, the labs, everything here. And the engineering is about curiosity and conversion of that curiosity to a broad investigation. And that's on being backward on like that. But so all those engineers become entrepreneurs, they have a passion beyond that particular product. They want to scale, they want to make the business out of it. And then we is still to have that something which really troubles me very when someone says that hey, by the way, what didn't person ignorate because machine learning job the market is so lucrative. So like look, if you want to learn machine learning, why you need a machine engineer? We could have done it, when you were, I don't know, in your teens. Actually, wise. Because you just need a fundament, and that's why we have opportunity in India. Okay, the cost of a build, which can give one sensitivity, is very very high. Imagine the kind of infrastructure which ambitious infrastructure required for everything. We cannot afford this. Actually, cannot afford the cost of compute, which is given by a large company that is relevant to their country, that is not relevant to India. Even the mechanics of motion, whether it is two-wheeler, whether it is three-wheeler, whether it is four-wheeler. Imagine if some other company outside of India was building two-wheelers in India. So I don't know how many people can even afford that kind of two-wheeler or three-wheelers. And that goes to the person which Akash is asking about areas, commercial markets. India is becoming one of the largest, aviation market, and especially airline market in India. Can they afford the kind of these elements which the rents in India like that versus today, waiting around to countries which are the largest suppliers, but we can be bigger.
We have zero aircraft company in India. Why is that? We have to solve that.
Yeah, so because not down just come and engineers and I've written, I've built robots, I've built machines, I've flown aircraft, I've written cross-compartment. I've also written ERP software. I've been a consultant also. I've worked for a company also. I've done all those kind of things. But at the core, engineers are very always curious. They are still very, very curious. And I think that is something which is, the moment you say that, hey, by the way, this is a 40 lakh rupees check and this is the data science or machine learning, these are the two things which are very in pocket. That's the job.
And we cannot blame that engineer for making that choice. This is some deep problem which is solvable or not solvable, I don't know, but someone needs to give respect to a chemical engineer who is creating an energy innovation which will transform the mankind. We are. I don't know what is the solution, or if we will be able to find that solution in our lifetime.
Almost like it's cheaper to calling the investment. Investment bankers need tons of money more than an engineer makes. But engineer competes with investment. So maybe we should take data science out of industry. Maybe we should take the AI of business.
But they need to be compensated. Why can I not get?
I think that's also an internal market. Just like happens in any product. So if I say that an engineer is a product, they have to find their monetary value in the industry.
Look, the values of what we need work cheap first, and it happens to be but what inside. Okay, DHA will go some Bell will go somewhere, and all these large public enterprises say they do their own exam. Hey, by the way, if you have to work on turbine, you have to be this. You have to have electrical or be mechanical, and then these EDV departments were created, way back even before law, right? And they would say that you have to be a computer science engineer, which was fine because we were looking at a particular apprentice-based career, which is fine. If somebody wants to pursue that, then go ahead. Okay, then go ahead. But then I would question that why do you even want to be engineer? You should explore far more. Chartered accountants will not. If you don't want to build things, if you want it's there are multiple ones. That's what are, I think, more than the starting one. But if you want to be engineering, the way is scale. Okay, they want to solve a problem and solve them what to become an entrepreneur. They want their solution to scale as a business. Then they can't say, hey, by the way, I am just kind of an engineer. Chance I heard so. Because in engineering, you have lots of, if you really are solving or if you're reading a problem, you cannot be just one type of engineer.
Yes, I am a mining engineer. I am a mining engineer.
In fact, IIT Delhi is planning to start a discipline, not a discipline, removing discipline and creating a BTech in general engineering. Because they're finding that some departments are using a product, teach them a bit of different things and then give them choices of what they want. Thanks, Akash. It was such a pleasure to listen to your insightful thoughts on the future of energy. And as Raviji says, I'm now confident that the energy, is future-proof for India. We'll also have to make education future-proof for the country.
Thanks a lot for having me, and it was a pleasure discussing with you and Ravi.
Nice. Thank you.